To get some intuition about how a quadrotor works, let's build one up piece by piece. To start with, let's take a single rotor and attach it to a mass representing the body or frame of the vehicle. This is the simplest possible helicopter. But what happens when the rotor spins? In this configuration, the spinning rotor has angular momentum, and through the conservation of angular momentum, it will induce a torque on the mass it's attached to, causing it to spin as well in the opposite direction. Not a great flying machine just yet. This is why a single rotor helicopter has a tail rotor mounted at 90 degrees to the main propeller to exert a torque in the opposite direction and keep the whole thing from spinning out of control. This is the most common design of manned helicopter vehicles. But instead of a tail rotor, you could introduce another propeller spinning in the opposite direction, like this. Now you have a dual prop helicopter, also known as counter-rotating propellers, and the net angular momentum from each of the rotors cancels each other out. This is an example of a dual prop helicopter right here. Now we could talk about adding a third rotor and how you could go about balancing out the torques from 3 rotors, but instead we're going to skip over that in favor of going right to the symmetric simplicity of the quadrotor. Quadrotor consists of 4 rotors attached to a frame, usually in an X shape like this. Rotors that sit opposite from one another on the frame spin in the same direction, and the 2 pairs of motors spin in opposite directions, so that when they're all spinning at the same speed, the vehicle can hover with a net torque of 0. So your basic quad now consists of a frame and 4 propellers. You'll also need motors to drive each of the propellers, an autopilot and flight computer to decide what the motor should do, sensors like GPS, an inertial measurement unit, or IMU, a camera to observe your surroundings, and a battery to power everything. And with that, you have a fully functional quadrotor drone. But the best way to understand how something works is to take it apart and investigate each of the components in detail. So that's what we'll do next.